Okay, this is the 5.4 notes for Math 3H. We're finding time of exponential and compound interest problems, and we're going to make sure by the end of the lesson we know how to use the intersect feature in the graphing calculator to find the time it takes for an exponential function to reach a certain value and the time it takes for an interest function to reach a certain value. So let's just review some of the formulas. If it's growth, it's 1 plus r to the t, and if it's decay, it's 1 minus. The simple interest is the principal amount times 1 plus r to the t, just the growth formula with a different initial value, calling it p instead of a. More than once per year is going to be 1 plus r over n times nt. And again, just if you ever wanted to and you want to not have to memorize an extra formula, the simple interest formula you can ignore. And when it says compounded, you just put 1 in for n. And then the continuously one is PERT, P-E to the R-T. Okay, so what we are going to be doing now is we are going to see how to use the calculator to find a point of intersection. So the first thing you're going to do is press y equals on there. Then you're going to enter in your two equations, and then you're probably going to have to adjust the window to make sure that you can see the whole graph and the point of intersection. So if we're doing our 2-pen approach, the first thing right here is that you have to see the intersection to be able to compute it. Okay, and then how are you going to see it? You're going to make sure that you follow these rules. Your x min is going to be -1. Your x max is just your guess of how much time. So 5 years, 20 years, 100 years, that kind of thing. And then your y minimum is going to be -1, and we're setting x and y at -1 because we're dealing with real numbers. So time, we don't go negative, so that's why. And then y max is more, the value more than your y equals number, which you'll see in a minute. Okay, so then after that, you're going to pull up the calculate menu. So you do that by hitting second trace, and then you're going to press 5 for intersect, and then you're going to press enter 3 times. Okay, so those are the directions. We're going to see it in action right here. So it says write the equations used to solve the problem, then solve for the time. So you're going to set up the equation using y1 equals and y2 equals. So what that means is this. Okay, a person invests $2,500 in an account that earns 2% annual interest. And it says find when the value of the investment reaches $5,000. So if we have our formula, which this is the simple formula right here, so I'm just going to make sure that I realize this is simple because it doesn't say compounded quarterly or semi-annually or anything like that. And my formula for that is P times 1 plus R to the T. Okay, and then I'm going to plug in. So what goes over here is the 5,000 because that's the final amount. Your initial investment or your principal is 2,500, and then your rate, remember, we always convert that to a decimal, so it's 0.02. 0.02, and the variable we're solving for is t, so we're trying to figure out how long it's going to take us to reach t. And so we are going to plug this into we're going to plug this into y1 in our calculator and this into y2. It doesn't actually matter which one you plug it into, it just matters that they each get their own line in the calculator. So let me pull up this calculator. And so we are first going to be hitting y equals, which is right below the graphing. And then from there, we're going to type in 5,000. And then we're going to go into Y2 and type in the other, which is 2,500 times 1 plus 0.02 raised to the x. Okay, so after you have those into the equation portion, then you're going to hit the graph. And I'm just going to have you hit graph real quick so you can see these equations being graphed, right? And what you notice is you do not see these equations being graphed because when you look back at them, your y value is 5,000, your y1 value. And our window is only between -10 and 10 in both the x and y directions. So we're going to use what we saw earlier in the notes right here, which is this stuff up here, and right here, and right here, and right here. So we are going to be doing setting our x minimum and our y minimum both at -1, and then trying to figure out approximately how many years it's going to take for it to reach where we want it to reach, the money we want it to reach. So we are going to set our x min to -1. So I just hit clear. And then how many years do I think it's going to take? I'm going to start with 20 years. I don't know. Don't worry about the x scale. Then we know our minimum is -1. And our y maximum, which is the y value, and it says more than your y1 number. So our y1 number is at 5,000. So I'm going to make this 6,000. Okay. And then I'm going to hit graph. So right now I have the two graphs. The y equals 5,000 is a horizontal line, and then I have the other equation from the interest formula, but I don't see the intersection. So what that means is that my guess at time, my x maximum, is not a good guess because somewhere over to the right it's intersecting and it's still not in my window. So I'm going to go back to my window and look at my x direction, and I guess 20. Now I'm going to guess 50 just to see. And then I hit graph. The actual TI graphing calculators will take longer to do these graphs. They're not instantaneous, but you can see. Okay, so now you can see that they are intersecting, and you see that intersection in the window of the graphing calculator. So then comes your next step, which is to hit the blue button, the second button, and then right below the graphing calculator screen is the word trace, and so we're actually pulling up the calculate menu for graphing. And then you're going to select option 5 and then just hit enter 3 times. Okay, second trace, enter, enter, enter. The actual graphing calculators in our classroom will not say left bound or right bound, so you are just going to hit enter, enter, enter. I have to do this on this app, so it's a little different. Okay, so right here, it'll tell you where the intersection is, and it says x equals 35.00279 and y equals 5,000. So we already knew they were going to intersect at 5,000 since that was one of our equations. What we are going to report is the x value, which is time, and we're rounding to 3 decimal places. So we're going to put right here, t equals 35.003 years. So when we're rounding to time, we are going to round to 3 decimal places. When it's money, it's obviously 2. So 2 pen approach. Okay, so now we're going to move on to the other ones, and it's just a bunch of plugging things into the calculator, adjusting your window according to the criteria that we gave, and seeing where they intersect. So let's go up here. A person invests $1,500 into an account that earns 4% annual interest compounded quarterly. So once I see that compounded quarterly, I automatically know that it's going to be the compound interest formula. So my formula is going to be P times 1 plus R over N to the NT. And now I'm just going to fill in the information. So they're investing $1,500. We always are going to convert our rate to a decimal. So that's 0.04 before we plug it in. We don't plug percents into this kind of formula. Quarterly is how many times per year. That means n equals 4. And we do not know the time. That's what we're trying to find. And then it says find when the value of the investment doubles. So investment doubles. So what did it start at? It started at 1,500. So what is that going to be when it doubles? So when it doubles, just double 1,500, and that's going to be 3,000. Okay, everything is right there. Then we're going to go into our graphing calculator, hit y equals. I'm going to change that and the top one to be my new equation. So I have 3,000 for y1 and 1,500 times 1 plus, and then you can always put it in as a fraction, and that is, you do that by hitting alpha y equals, so the green button, and then the y equals button, and then you do n over d, or you can just put it in as a division problem, divided by, why is it? I'm just going to type that in. I don't know what's going on. You could just do it like this. 0.04 divided by 4 raised to the 4x. So we don't have a t button, so we're going to do x and then hit the graph button. And if your point of intersection is in the same viewing window as what you used before, you're good to go. So since it is in the same viewing window, now we just need to find it. So second trace brings up the calc menu, select option 5, and then you hit enter, 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 okay? You aren't going to have to do what you see me doing right now because it's a different calculator. Okay, so enter, 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 and you can see that your time is right there. And because it's not money, it's time, we're going to be rounding to 3 decimal places. So again, we plug this into y1 and this into y2 to figure out where they intersect. And we get t is approximately 17.415 years. Okay, we're just going to keep doing this for the remainder of the problems. So let's see. This next one says a person invests $6,000 into an account that earns 3.2. So 0.032 is our rate. Compounded continuously. So once I see the word continuously, I know it's the E one. And we're finding when the investment reaches 9,000. So it's y equals PE to the RT. And I'm wondering when it's going to reach 9,000. It started at 6,000. We have E to the 0.032 times T. So y1, y2. Now, I have a feeling our viewing window isn't going to work because look right here. We have this number at 9,000. Our other maximum in the previous problem was not 9,000. The biggest number we picked was 3,000 or 6,000, so we might have to adjust our window. So not might, we will. So let's do that. So y equals, this one's 9,000, and this one is 6,000. The E button is kind of to the left of the 4. You have to hit the blue button and then the LN button, and then 0.032 to the X. And then I'm going to hit graph. And you can see we cannot see anything in this window. So what we're going to do is go back to the window, and we are going to change our Y value. I'm going to leave the X maximum at 50 because I think it's going to be fine, but I'm going to change that to 10,000 because that's like 1,000 greater than 9,000, and hit graph. And now you can see right there is where the graph is intersecting, but we're not just going to use our eyeballs. We're actually going to let the calculator find the exact point of intersection. So second trace, option 5, enter, enter, enter. That's all you have to do. Don't pay attention to what I'm doing on here because the program, the app is a little different. Okay, so there we have our answer. Okay, so it's always the x-coordinate of the intersection. So we are going to get that t is approximately 12.671 years. Okay, next one, little different. It says a lake contains 563 fish. If its population increases by 9% each year, how long will it take for the population to reach 795 fish? So this is going to be growth. So we're going to start with y equals a times 1 plus r to the t. And we're trying to get to 795 fish. We started with 563. Our rate is 0.09. And then it's to the t. So we're going to plug this into y1 and this into y2. So I just want to point out real quick that this right here, that y1, is 795. In the last problem, we were at 9,000. So this is significantly smaller. So I already know I'm going to have to change my viewing window. Okay, so let's go into the graphing calculator program. Y equals clear, x equals clear. I'm just going to clear everything. Y equals y1. We have 795. And y2 is 563 times 1 plus 0.09, which is actually just 1.09. Yes, you should simplify that, raised to the x power, because we can combine like terms, so we do. And then we're going to hit graph. And yes, you can see the point of intersection in there, but it's going to be really hard to calculate it. So just go back to your window, and instead of 10,000, I'm just going to change it to 1,000 so I have a better picture. My X window is really big. We don't really have to change it, but I'm going to change it just because I like it to be more realistic and like not realistic, better in the graph and in the viewing window. You don't have to. Second trace, option 5, and then you're going to hit enter, 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 and then we have our answer right there, the x coordinate. So we go here, and then I get that t is approximately 4.004 years. Moving on to the next one. A painting is worth $75,000 and is increasing at a value by 12% each year. So 0.12. How many years will it take to reach a value of $1 million? So we are going to still be using, this isn't an interest formula, it's a growth formula, even though that they're similar. This is 750,000 times 1 plus 0.12 raised to the t. And then we are going to plug into that, which is $1 million. So look how big this number right here is. Look at that right there. That number is $1 million, right? And we just changed our viewing window to be 1,000. So we need to make it bigger than that. So we are going to plug this in for y1 and this in for y2. So we are going to the graph, clear everything out. Y equals, this is 1 million. And then this is 750,000 times 1.12, because when I combine like terms, that's what I get, raised to the x. I'm not even going to graph this right now because I know I'm not going to be able to see it because my window is set to 1,000 and our number is 1 million. So I'm just going to do like 1,100,000. So I'm slightly bigger and then hit graph. And I see the point of intersection in the viewing window. Second trace, pull up option 5, and then you're going to do enter, enter, enter. And there we go. It's only going to take that investment because it's increasing at a rate of 12% to increase by 250,000 because it's going 750,000 to a million. It's only going to take 2.538 years. And our last problem, slightly different, but that's okay. We will see how we do this, okay? So this one says you buy a brand new car for $36,000 in 2023 if its value depreciates. So depreciates is a word. Appreciate increases, depreciate decreases. So this is going to be decay. 8.3%, so R equals 0.083. In what year will the car be worth half its purchase price? So half of 36,000, which is going to be 18,000. So this is a decay model. So A equals, or sorry, I was using A. You could use the A, it's fine. But this is going to be Y equals A times 1 minus RT. So that's going to be, the half of that is 18,000. The starting amount was 36,000. And then it's going to be 1 minus 0.083 to the T. I am going to do this math in the calculator. And instead of being 1 minus 0.083, that's going to be 0.917. So then I'm going to put this in Y1, this in Y2. So clear everything out. And then 18,000. And then it's going to be 36,000 times 0.917 raised to the x, and then hit graph. It's really hard to see that point of intersection because we went so big. So I'm going to go back to my window and I'm going to change the y max. The y value is 18,000, so I'll just go with 20,000. And then that's better. If you want, you could make it bigger, you can make it lower, but I'm just going to go right there. You can see the red graph is now coming down because it's decay. Second trace, option 5, and then enter, enter, enter. And then it'll give us our value of 7.9995. So we will round that. If we're rounding to 3 decimals, go to the fourth one, and the 5 is going to change all those. So that's going to be y equals 8.000 years. And then we're just going to be making sure that we did read our question properly because it says, in what year will the car be worth half its purchase price? In what year? The 8th year. So it's actually going to be 8 years later. So if we started in 2023 and we add the 8 years, it's going to be during the year 2031. And that's it.